Hello everyone. Good morning. I am Nikunj, your physics teacher from QNI, and I welcome you all to the QNI class. How are you all? Good morning everyone. Okay. So in the last class we were discussing about the friction, types of friction, the static friction, sliding friction, and rolling friction. So is there any doubt in the static, rolling, and kinetic or sliding friction? Yes. Very good. We know that static friction is a self-adjusting in nature. Okay. So when there is no relative motion between the two surfaces, the friction is static, and when there is a motion, there is kinetic friction. Okay. And rolling friction is the when we are using a wheels, so friction is rolling friction. Okay. When there is a rolling of a body or rotation of a body, the friction acting is rolling friction. Now we'll start today's lecture, but before starting the lecture, we will see what are the prerequisites. Okay, so the first one is force and then about friction. Okay, so these are the prerequisites for today's lecture. Now, if we talk about the weightage, so approximately 7 to 8 marks question asked from this chapter and what we're going to study today. So first we will see what is fluid friction. Okay, after that we will see what are the factors affecting force of fluid friction. Okay, what are the streamlined bodies, and then we will solve some questions also. Okay. Okay, so let's start today's lecture, which is fluid friction. Okay, so we know that whenever an object moves over the surface of another object, friction force, that is solid friction, comes into play. Okay, it may be static, it may be sliding, it may be rolling. Okay, is it clear? Yes or no? Okay. So, but what happens? Question come in our mind that what will happen when an object moves through air? Okay. So the air also exerts a force of friction, even though it is very light and thin. Okay. So we call this friction as air resistance, and it also opposes the motion. It also opposes the motion of objects through it. Okay. So you can observe this by activity. Okay. Suppose this is the ground. Okay. Now we have a sheet of paper and we have a crumpled sheet of paper. Now what will happen when we release both of them with the same height at the same time? So you will see here that if we drop both of them at the same time, so you can see the crumpled paper fall earlier than the sheet of paper. So can you tell me what is the observation here?
Sir, the crumble paper is more dense.
Okay. So can we say the air resistance or the crumpled sheet of paper falls with a greater speed? Yes or no? So
Yes,
why did
sir.
this happen? Okay, because of the resistance of the air. Because of the resistance of the air. Okay, suppose you have a feather and a crumbled paper. So again, if you drop both of the bodies, so time taken by the bodies to reach the ground will be different. Yes, because medium has a air. But when you perform this activity in the vacuum, so you will observe that both of these objects will fall on the ground at the same time. Because if there is a vacuum, that means there is no air, and if there is no air, then there is no resistance to the motion. Okay, so if the object is fall in air or in any medium apart from air, okay, so there is resistance offered to the body which is opposing the motion of the body. Okay, so here in case if the medium is air, so the resistance offered by the air is resistance of air, which we call the fluid friction, because we know fluid may be liquid or may be gas. Is this clear to everyone? Any doubt? Yes or no?
No, sir.
Okay, very good. So air resistance acts to the direction opposite to the direction of motion of paper, as in case of a solid friction also. In case of solid friction also, friction is acting opposite to the direction of motion. Similarly here, air resistance is also acting opposite to the motion of paper. Okay, if we have a sheet of paper, so it is going down. Okay, now the acceleration is acceleration due to gravity, but again some air resistance acting opposite to the direction of motion, which is in upward direction. Okay, very good. Now we'll see what are the factors affecting force of fluid friction. So can anyone tell me any factor which affecting the force of fluid friction by observation here? What are the factors which affecting the fluid friction? Yes, Isabel, Sudipti, what are the factors affecting the force of fluid friction here?
So wind,
Yes, please repeat. Please come again.
wind,
Wind. Okay, that means medium. Okay. Any other observation? Yes, Isabel. Govina. Tell me anything that comes into your mind. Yes, Venpa, Tamizai. Yes, B. Muthuselvi. Tell me what is the observation? What are the factors on which fluid friction is depending? Okay. Let's see. First is the object speed. Okay. So if faster objects experience greater fluid friction due to more frequent collision between the object and the fluid molecules. Yes or no? If object speed is more, here, if object speed is more, so what will happen? Everywhere the medium particle is air. So if object speed is more, so there is molecules of air. Yes or no? There are molecules of air and they are colliding at the faster rate. And if they are colliding at the faster rates, or they are providing more friction. Yes or no? If there are more number of collisions, so they are providing more friction. Yes or no? Yes, tell me.
yes, sir.
Okay. Now second is the object shape. So first we have taken the Grumple sheet, and in the second case we have taken a flat sheet of the paper. So the streamlined or aerodynamic shape minimize drag by allowing fluids to flow more smoothly around the objects. Yes or no? Okay. And if there are non-streamlined shapes like a flat plate, they experience more resistance. Okay, now if we talk about the fluid's viscosity, now viscosity is nothing but viscosity means the fluid resistance. Just simple understand here that what is the meaning of viscosity. So viscosity is nothing but the resistance offered by the fluid. Viscosity is resistance offered by the fluid. Okay, as in case of solid bodies, we know resistance is friction, static friction, rolling friction, sliding friction. So similarly in fluid, resistance is known as viscosity. Okay, so if fluids have higher viscosity like honey, they create more friction than lower viscosity like fluids like water. Suppose you have two beaker. Okay, you have two beaker, one is filled with water, one is filled with water, and second is filled with honey. Second is filled with honey. So in which of the case you can easily stir, in the first one or in the second one, in case of water or in case of honey? If we
And
have two,
water.
in water, yes, because honey is more dense, so it is providing more friction. We can say honey is more viscous than water. Yes or no? Honey is more viscous than water. Honey is providing more resistance. So fluid friction also depending upon the medium, which medium you have taken. You have taken water, you have taken water or air or honey, kerosene, turpentine. So for different mediums, resistance offered by the medium is different. Okay? Yes or no?
Yes, sir.
Very good. Now second is the fluid density. Okay. So again, we know if the density is more, so resistance offered by the fluid is more, as in case of water and honey. So we can say honey is more dense than water. Honey is more dense than water. So it is easier or we can say the water is providing less resistance to the motion as compared to the honey, because honey is more dense. Okay, so if fluid density is more, they will provide more resistance than less dense fluid. Okay, now again the object size and surface area. So as in the case of crumble sheet, the surface area is less, yes or no, as is compared to the sheet which is a flat, yes or no. Okay, so the larger objects with larger surface area experience more friction, yes or no? Any doubt till here?
No,
Yes,
sir.
then okay. Then is the nature of the fluid. Okay, again, fluid with higher internal resistance, like honey, will create more fluid friction than the fluid which have low resistance value. Okay, so any doubt in the factors affecting fluid friction in anyone? What fluid density, object size, surface area, nature of the fluid, fluid viscosity? Any doubt? Object shape, object speed? Okay, very good. Okay, now we'll see what is the meaning of streamlined bodies. Okay, so you can see aeroplane, you can see ship. So where do you think the shape of these machines got inspired from? Any idea that why aeroplane is not of the shape of rectangle or square or something like that?
Sir, sir,
Yeah,
can I?
yes, yes.
Sir, it's because the wings allow it to cut through the air so it can flow freely.
Yeah, and from the nature itself, okay, you can see the fish shape. Okay, they are called the streamlined bodies. Okay, or you can see the bird shape, fish shape. So we know that they swim or they flow in air or in water. Okay, so they are streamlined bodies. Okay, means streamlined bodies means they easily flow in the air or in water. Okay, they can easily flow in the air or the water. Again, sport vehicles are also designed so that air flows smoothly over the surface, providing the less resistance to the motion. Yes or no? Providing the less resistance to the motion. These are called the streamline flow. Okay. So again, nature gives some useful ideas to the mankind. Okay. So streamlined flow of air helps reduce the friction of air and helps them to acquire a faster speed. Okay. We cannot take any random shape of the objects like aeroplane, ship, bike, car. Everything is perfectly designed so as to minimize the friction offered by the air. Okay. And these are called the streamlined bodies. Yes, any doubt?
No, sir.
Okay, so let's have a quick revision of this chapter. Okay, first we studied that what is friction. After that, we studied types of friction, which is static, kinetic, and rolling. Static friction means when we have two surfaces in contact and they are not, there is no relative motion between the two surfaces in contact. So the friction acting between the two surfaces, static friction. And we know that static friction is self-adjusting in nature, and there is some maximum limit of the static friction which is called limiting friction, up to which the static friction can act, and the static friction is directly proportional to the applied force. And when there is a relative motion between the two surfaces, the friction acting between the surfaces is sliding friction, or we say it is kinetic friction. Sliding friction or kinetic friction. Yes or no? Now, if there is a rolling of the body, so the friction acts is called the rolling friction. Yes or no? Any doubt till here?
Yes, sir.
Yes, tell. Okay. Now we'll solve some questions based on this friction. Okay. So the first question is, a rough carpet causes shoes to stop quickly while a marble floor let them glide further. So how does the surface roughness affect friction in these cases? Which option is correct? First one is smooth surfaces always stop objects. Rougher surface offer more resistance and increase friction. Rough surfaces reduce contact and friction depends only on weight. Okay, the first option is smooth surfaces always stop objects. This is incorrect. Rougher surface offer more resistance and increase friction. This is correct. Rough surface reduce contact. No. Friction depends only on weight. No. Friction also depend upon the nature of the surfaces. Okay. So option B is correct. Okay. Very good. Rougher surfaces offer more resistance and increase friction. Very good, Preeti. Now, second question. When a ball rolls on the ground, it covers more distance than when dragged. What advantages does rolling friction have over sliding friction? Yes, tell me what is the answer. Rolling friction is stronger and causes quick stop. Rolling friction requires more energy. Rolling friction is lesser than sliding friction, reducing resistance.
Is lesser than the sliding friction, reducing resistance.
Very good. Okay, so first one is rolling friction is stronger and causes quick stop. No, this is incorrect. Rolling friction requires more energy. No, because we know rolling friction is the least. Okay, now rolling friction is lesser than sliding friction, reducing resistance. This is correct. Rolling friction increases roughness. Very good. Option C is correct. Very good. Okay. Now, next question. Aircraft engineers often design aeroplane noses to be narrow and the bodies streamlined, as we saw in the diagram. Okay. So why is this shape preferred for high speed travel and fuel efficiency in flight? First, it increases air drag and slows the plane. It reduces air resistance, allowing the plane to travel smoothly with less fuel consumption. It helps trap air for easier takeoff. It allows more luggage space inside. Okay, option B. Okay, if the body is streamlined, so there is less resistance. Yes or no? So it will decrease the air drag. Okay, so option
Sir,
A
it
is
reduces air resistance.
yes, but it reduces air resistance, allowing the plane to travel smoothly. And if resistance is less, so the fuel consumption will be less because the resistance is less. Yes or no? So option B is correct. It helps trap air for easier takeoff. No. It allows more luggage space inside. No. So option B is correct. Very good, everyone. Now, next question. While cycling, a student applies oil to the chain and notices smoother paddling. What role does lubrication play in reducing friction? And why does it enhance movement? Which option is correct?
Sir, C.
Okay.
Option C, lubrication forms a smoother layer, reducing contact and friction.
Friction. Very good. Very good, everyone. Very good. So first is lubrication increases friction and heat. No. If lubrication in fact decreases the friction and if friction is less, so there is low heat produced. Okay. Now second, lubrication blocks energy transfer. No. In fact, energy transfer is getting smoother after lubrication. C option is lubrication forms a smooth layer reducing contact and friction. Correct. Lubrication erodes the surface. No. So option C is correct. Any doubt?
No
Yes,
doubt.
any doubt? Okay, any doubt in the chapter in any topic? Anyone, any doubt in the chapter in any topic?
No,
Sir,
sir.
Sir, I got confused with the problem, sir. I can do the Newton, but like the meter per second, those questions I get confused.
Please come again, Vinapa.
Sir, the questions where it says, so this car is traveling at this meter per second, like that questions I get confused.
Okay, so in the question that is given velocity is some meter per second, after some time velocity is some meter per second, and time taken by the body is some second. So what is the acceleration? That type of question?
Yes, sir.
Okay, so here you are requiring a knowledge of acceleration. Okay, I will tell you. Suppose in a question like given that let's say at point A, speed of the body is let's say u meter per second. Speed of the body is u meter per second, and let's say body reaches to point B with the velocity v meter per second. Are we clear till now? initial speed of the body is u meter per second, final speed of the body is v meter per second. Now suppose body is traveling on a surface. Suppose there is a surface and there is a car, and the car, let's say at point A, car is having a speed of you can say 10 meter per second, and let's say car reaches to point B. Car reaches to point B. Let's say speed of the car at point B is 5 meter per second, and time taken by the body from A to B is 5 seconds. Now we have to find the deceleration or acceleration provided by the resistance. Now we know that resistance, or you can say friction is acting opposite to the direction of motion. Yes or no? So if car is going from A to B, friction is acting in opposite direction. Yes or no? Friction is acting in opposite direction.
Yes, sir.
Okay. Now tell me one thing. Suppose a body is going towards right side, let's say with a speed of 10 meter per second. Okay. Now I'm applying a force towards left side. So what will happen? Speed of body will decrease. Yes or no?
Yes, sir.
Speed of body will. Okay, very good. Now that means this force is opposing the motion. This applied force is opposing the motion.
Yes, sir.
Okay. Now because of which speed of the body will decrease. So that means, can we say here the acceleration or deceleration? Now what is the meaning of acceleration? Acceleration means the speed change in velocity with respect to time. What is the meaning of acceleration? Meaning of acceleration is change in velocity or change in speed upon time. Okay. So now in the second case, suppose I'm taking the same body. Now this body again going with the 10 meter per second towards the right side and applying a force again in the right side. Now tell me, with respect to time, speed will increase or decrease? If body is
Sir,
going to,
can you say that again?
if body is going toward right side with the speed of 10 meter per second, let's say, and I'm applying a force towards right side, so speed will increase or decrease?
Increase.
Increase. Very good. So in the first case, speed will decrease. In the second case, speed will increase. Okay. So in the first case, we are saying that force is opposing the direction of motion or opposing the motion, and in the second case, force is supporting the motion. Okay. In the second case, force is supporting the motion. So in the first case, we say the body is decelerating. In the first case, we say the body is decelerating. In the second case, we used to say that body is accelerating. Is this clear? What is the meaning of deceleration and what is the meaning of acceleration? Acceleration means speed of the body will increase with respect to time, and deceleration means speed of body will decrease with respect to time. Any doubt
Yes, sir.
here?
No, sir.
No. Now let's consider this case of the car in which speed of the car at A is 10 meter per second and at point B speed of the car is 5 meter per second. That means, can we say here friction is opposing the motion, acting opposite to the direction of motion?
Yes, sir.
Very good. So that means, can we say here from A to B the body or the car is decelerating?
Yes, sir.
Okay, very good. Now we have to find that what is the deceleration. So we know that acceleration or deceleration is equals to change in velocity upon time. Now tell me, what is the velocity of the body at point B? What is the velocity of the body at point B?
10 meter.
At point B, it is 5 meter per second. Okay, so 5 minus initial velocity of the body is 10 meter per
10
second,
meter.
and time taken by the body from A to B is 5 seconds. Yes or no?
Yes, sir.
Okay, So upon 5. Now 5 minus 10 is minus 5. Minus 5 upon 5 is minus 1 meter per second square. So deceleration of the body is here minus 1 meter per second square. Now suppose in the second case, if I'm taking the same car, now let's say the acceleration of the body or of the car at point A is 5 meter per second and at B speed of the car is 10 meter per second. Now if in question it is asked that find the acceleration. So again, what is acceleration? Change in velocity upon time. Now in the second case, if we want to calculate the acceleration, so tell me what is the acceleration of the body at point B? 10 meter per second? Yes or no?
Yes, sir.
Speed of, okay. Now what is the initial speed? 5 meter per second. And what is the time taken by the body from A to B? 5 seconds. Okay. So 10 minus 5 is 5. 5 upon 5 is equals to 1 meter per second square. So in the second case, acceleration is positive, which is 1 meter per second square. And in the first case, acceleration is negative, which is minus 1 meter per second square. Yes or no?
Yes, sir.
So both, so we call this as deceleration, and 1 meter per second square is the acceleration of the body. Okay. Now, if acceleration is positive, that means speed of the body will increase with respect to time.
Yes,
And
sir.
if acceleration is negative, so we used to say it is deceleration, and in that case, speed of the body will decrease with respect to time. Yes or no?
Yes, sir.
Clear? So now can you find acceleration or deceleration if it is asked in the question?
Yes, sir.
Now, any doubt to anyone? Yes, anyone having any other doubt? Is the concept of acceleration or deceleration clear to everyone? Yes, tell me. Isabel, Sudipti, Rishmita.
Yes, sir.
Okay, very good. Now we'll solve next question. Now, which activity demonstrates drag acting opposite to the motion? So, which option is correct? First, a parachute slowing down as it falls through air. Second, a block sliding on a smooth surface. Third, a ball rolling on a flat ground. D, a feather floating without resistance. What is the answer? A, B, C, or D? A. Okay. Yes, what about others? A or D? Okay. D.
So it's A, sir.
A. Okay. Okay. So some of you are saying A, some of saying D. Okay. So the correct answer is A, that a parachute slowing down as it falls through air. Why? Because in
Sir,
the
it,
D option, yes,
it
yes,
can't
yes,
be
tell
D
me.
because it says a feather floating without resistance. If it has air resistance only, it will be eligible for this question.
Yes, very good. So option D is incorrect because it is given that feather floating without resistance. So if there is no resistance, so there is no meaning of drag. Okay. If there is no resistance, then there is no meaning of drag. Yes or no? Isabel and Sudipti, is this clear?
Yes, sir.
So option D is incorrect. Correct option is option A. Okay. Is this question clear to everyone? Any doubt? Okay, very good. Now, next question. Which activity demonstrates thrust countering drag? A. A plane's engine pushing it forward against air resistance. B. A ball rolling downhill without resistance. C option. A feather floating without any motion. D option. A block sliding on rough surface.
Sir, what is thrust meaning?
Last option. A block sliding on a rough surface.
No, sir. What does thrust mean? Which activity demonstrates thrust countering? What does that
Thrust
mean?
means a force required for takeoff. You can understand
Okay,
like
sir.
this. Okay. So which option is correct? A, B, C, or D?
Yeah.
A option. Okay. A. Okay. So correct option is option A. Very good. That a plane engine is pushing it forward against air resistance. Okay. So thrust is required to take off. Okay. Now again in the C option it is given a feather floating without any motion. So if there is no motion, so there is no meaning of thrust or countering drag. Okay. And a ball rolling downhill without resistance. Again, this option is incorrect. Now a block sliding on a rough surface. So if a block sliding on the rough surface, there is no meaning of drag. Okay. Is this clear to everyone? Any doubt in this question? In any option? Okay, very good. Now, next question. Which activity demonstrates the effectiveness of a streamlined shapes in reducing drag? A fish swimming easily with a streamlined body, a cube moving in water with difficulty, a ball rolling on a rough surface, or D option, a parachute falling
A,
slowly
sir.
due to A.
A.
Very good. Okay. Okay, what about others? Okay, very good. A fish swimming easily with its streamlined body. Okay, any doubt in any option? That why B, C, D is incorrect. Okay, okay. Next, which activity demonstrates drag increasing with speed? A cyclist paddling faster feels more air resistance, a block sliding on a smooth surface, a block rolling on a flat ground, or D option, a parachute falling at a constant speed. Yes, A option. Okay, very good. A cyclist paddling faster feels more resistance.
Sir,
Okay,
can you
any doubt?
explain why? Can you explain why it is?
Which activity best demonstrates drag increasing with speed? So as we saw in this lecture, today's lecture, that what are the factors affecting fluid friction? Object speed, yes or no? What are the factors affecting fluid friction? First one is the object speed. Now, if
Yes,
speed
sir.
is more, so that means there is more drag. Because if someone is cycling, okay, so the medium is air. So air will provide resistance to the motion, yes or no? So if the speed is more, the drag will be more, yes or no? Now in the D
Yes, sir.
option, it is given that it is falling at a constant speed. So there is no meaning of increasing or decreasing the drag. Okay.
Yes,
So
sir.
correct option is option A.
Okay, sir. Thank you, sir.
Okay, very good. Any other doubt? Yes, any other doubt to anyone?
No, sir.
Very good. Okay, now this is a homework, that which activity demonstrates drag opposing motion. Okay, tell me the answer. Which option is correct? A option. Okay. Option A is correct. A parachute slowing down as it falls, because here drag is opposing the motion, because we know as parachute will fall, the friction or the air resistance will acting opposite to the direction of motion, that is opposite to the direction of the parachute. Okay. Is this clear? Again, D option is incorrect. Why? Because it is given without resistance. Is this clear to everyone?
Yes, sir.
Very good. Now, next, how can the friction between rolling objects and the surface be tested in lab? First, by measuring the object speed on different surfaces, by weighing the object before and after rolling. C option, by calculating the distance the object travels in water. D, by noting the angle of inclination of the object. By noting the angle of inclination of the object. So which option is correct? We have to calculate the friction between rolling objects and the surface. Yes, tell me which option is correct.
Option A, by measuring the object speed on different surfaces.
Okay, because we know that force of friction depending upon the two factors. First, the nature of the surfaces in contact, and the second, the force with which it's pressing down. Yes or no? Yes, tell me what are the two factors on which friction depends? First, the nature of surfaces in contact. If the surface is smooth, friction will be less. If the surface is rough, the friction will be more. Okay. And if we increase the pressure, or if we increase the force from the upper side, so there is more resistance to the flow. Yes or no? So these are the two factors on which the friction is depending. So by measuring the object speed on different surfaces, because if we change the, suppose this is surface A, this is surface B. So if we change the nature of the surface, so accordingly friction will change. So we can measure that by what amount the friction is changing. So we can measure the friction of the rolling objects on the different surfaces. Yes or no? Is this clear? Now D option is saying by noting the angle of inclination of the object. Okay, so if you keep the surface same, that is everywhere surface is A. Now if the angle of inclination is different in different surface, if the nature of the surface is same, so friction will be same in each of the case. Yes or no? If the nature of the surface is same in all the cases, so friction will be same in all the cases. So there is no difference in the friction. Yes or no? So option D is incorrect. Now we know that in water, friction is fluid friction. So in water, we can't measure rolling. Okay. Now B option, by weighing the object before and after rolling. So just by measuring the weight, we can't tell the value of friction. Okay. Is this clear to everyone? Any doubt in this question? Yes or no?
No doubt, sir.
Okay, very good. Now, next question, which activity demonstrates the role of wheels in easing movement? Moving a trolley on wheels versus dragging it, sliding a book on a polished table, C, dragging a block on sandpaper, or D, dropping a ball onto a flat surface. Very good. Correct option is option A, that moving a trolley on wheels versus dragging it. Because we know, suppose if we have a bag on a flat surface, let's say of 10 kg, and if we are pulling it, so we're requiring some force, let's say F1. Now on the same surface, I'm not changing the nature of the surface, and we're this time again we're taking the same bag which is of 10 kg. Now this time I'm attaching a wheels to the bag. Now this time let's say force is F2. So we know that F2 will be less than F1. By adding the wheels, we're requiring a less effort in pulling it. Yes or no? So how we can demonstrate? So by moving a trolley on wheels versus dragging it. Is this clear to everyone?
Yes, sir.